Mm. Hi students. In this computer networks lecture series, so today the topic that we are going to discuss on transmission control protocol. I think you are all aware of this topic. This topic comes under that unit of unit 4. So before that I'll introduce myself. I am S. Logesswari from RMD Engineering College, working as an assistant professor in CSE department. The topic that we are going to discuss is about transmission control protocol. So we already know that this is one of the main protocol in the transport layer. Without this protocol, we can't able to send our data with safe and secure. That is our main objective of this protocol. Let's move on to the session, like how this protocol will be working, what are the main contents are there, what are the main features are there, what is the frame format. Those things will be discussed in this lecture series. So basically we have in transport layer we have two different types of protocols are working. One is the connection oriented protocol, next one is the connectionless protocol. So example for connectionless protocol is the user datagram protocol. It is an unreliable datagram protocol. Why? Because we doesn't have an acknowledgement, we doesn't get an acknowledgement while we are sending the data. But in case of TCP, we will be getting the acknowledgement so that we come to know that the data has been reached to the sender in a safe and secure manner. But so whenever we are in the internet also, we are combining two protocols, which is called as the TCP as well as the IP. Another advantage of using TCP is that it can able to control the congestion also. So that's why we are combining these two protocols. So this transmission control protocol is an reliable protocol. Reliable means withstand to failure. Even if the failure has been happened, it can able to recover the message or retransmit the message. So those things and all done with the help of TCP. So some common applications still need a more reliable service. Best example is our email, that what we are sending is works under the concept of TCP IP protocol only. So this is the layers, like in each and every layer some sort of protocols are working. In the third layer, IP protocol, ICMP, IGMP, ARP, RARP are working. In the fourth protocol, two major protocols have plays a crucial role. One is the TCP, second one is the UDP. Okay. SMTP works on TCP, FTP also works on TCP. TCP and UDP, TCP works based upon the UDP. So what are the basic properties of TCP? Is a stream oriented approach. So why I am saying as a stream oriented approach means each and every data will be processed from sender to the receiver with a streamed sequence which is of in order with the help of the sequence number. Next one is that if we are going to use TCP now, you should have three steps. First, you should get the connection establishment, data transfer. Finally, you have to disconnect or terminate the connection, which is called as the connection redirect, and then it processes a reliable data stream because it is having all error direction recovery applications. It will be done. So this is the example how this network will work. So so here says that how the stream delivery, here the stream bytes will be processed from from the sender to the receiver. Next is that is a buffer transfer because it provides the flow control. It provides a flow control because if I am having the fast sender but the receiver is very slow, means I have to I have to match the capabilities between the sender and the receiver. I should have the buffer so that the buffer will store all the data. Whenever the receiver is free, then come to the buffer and take it or process the data. So that's why it is called as the buffered services. And then it is an unstructured data stream. It is a continuous, okay, doesn't have any boundaries and all. Next one is the full duplex communication, as well as the half full duplex means both the directions they can able to send the data. So apart from that, we have a stream identification number. TCP uses port numbers, which is very important because port number defines which application needs this particular data. So which is TCP is having the socket address. Socket consists of port number and the IP address. So some applications are assigned to the well-known port number. These port numbers are unchangeable, can't able to change. It is and all well-known port numbers. So and then it provides the reliable transport for here, which is using a protocol called as the HTLC protocols, high level data link control protocol. Whenever I'm sending the data, I'll be getting an acknowledgement also. So for each and every datagram, the timer will be there, same as it is the working concept as it is in the sliding window protocol or whatever it is. So a timer will be there. Before the timer expires, the data has to be reached to the sender receiver, as well as before the timer expires, the acknowledgement has to be reached from the receiver to the sender. So then only the sender will come to know that the particular data has been reached to the receiver in a safe and secure manner, or else it will think it of like it will be considered as a data loss. It starts to do the retransmission. So and then it will using the main protocol called as the sliding window protocol. In sliding window, you can send as many as data, and then we will be getting one single acknowledgements. And then here the TCP flow controller is sending in the frame of a stream of bytes, and then bytes are divided into chunks, and then each segment will be having a timer. So within the particular timer expires, it has to reach it to the receiver. So as well as it will be having the checksum. Checksum is used to find out whether the data which has been received at the receiver side is it correct or not. So that will be checked with the help of the checksum. It is used for an error correction as well as for the duplications also. So these are the same thing, as well as we have a acknowledgement numbers. Acknowledgement number is very important. And then so these are the TCP windows. The bytes which are acknowledged are moved from the window, and then once we get the acknowledgement, we will slide the window to the next unsent data. Okay. And then this is a sending buffer and this is a receiving buffer. Whatever the data is here in the sending buffers, we will be having 3 chambers, but in the receiving buffers we will be having only 1 chamber. So here you can see the 3 chambers are, so you can see that one is an empty, another is a pink shade, another one is a gray shade. So the empty shade indicates that next byte to accept, and then pink shade indicates the next byte to be sent, and then the gray shade indicates that these bytes has been sent and we got acknowledgement also. But in this receiving TCP, you will be having only 1 chamber. It is used only to store the data. Okay. So this is sending buffer and receiving buffer concept. Same thing only. And then here you are using some flow controls. So when the TCP asks to acknowledges the data, it indicates the next byte in order with help of the cumulative acknowledgement. You also called as a picky packing. If there is any congestion occur, automatically it will slow down the data rate so that it will avoid the data traffic. I can able to extend my window size as well as I can able to shrink my data size. So finally we have this very important, which is called as a TCP segment format. So along with the header, so I am sending 2 details in the while sending the data. One is the header, next one is the data. So in this header itself, it consists of different informations like source port address, destination port address, sequence number, acknowledgement number, length, reserved bits, and then we have some 6 flag fields are there, and that window size will be determined, checksum is there, and urgent pointer is there. So and then actually we have 6 flags are there. So one is the urgent pointer or urgent flag, next is acknowledgement, next one is push, reset, sync and fin. So urgent indicates that it's not conditioned that every flag is going to be enabled over there. Depends upon the situation or depends upon the data, these flag will be enabled. If I set urgent flag has to be enabled, means it will process the data. It indicates that this data packet consists of very urgent information we should process the data as soon as possible. And then next one is acknowledgement, means it indicates that doesn't carry any data, it carries simply the acknowledgement. And then push means we have to process the data as much as faster. And then if there is any problem in the connection or the data transfer, we can do the resetting, so that is said to be reset. And then finally one is sync. Sync is very important while we are starting the data connection. So I should synchronize with the sender and the receiver. That's why I'm enabling the sync flag. And then once the connection has been finished, data transfer has been finished, I'll go with the fin segment. And then I can choose the window size, I can use options and paddings also. So these are all the main thing. Okay. So this is all about TCP and the features of TCP. Thank you, students.